Hey guys, do you need code? Welcome to my channel. In this video, we're going to go through this Leetcode number 105, construct binary tree from post, pre-order, and in-order traversal. So let's look at the example in here. We are given an array. So basically, the left-hand side is the pre-order numbers. With all the numbers is the value on the node. For example, 3, 9, 20, 15, and 7. So because it's the pre-order, and whenever it says pre, actually it's talking about the root. So pre means the root goes first. So that's why it's 3, 9, 20, and 20 is the root. That's why it needs to go first for the right branch. So 20, 15, and 7. And in order means that to me, that means is the root node comes second. So as you can see for this tree, because the root comes in second, so the left first, and then root, and then to the right, right? So it's a 9, 3, should be 20, but within this branch, the root comes second. So the left comes first, so 15, 20, and 7. So this is how we can represent a tree using pre-order and an in-order representation, traversal. And so we are given these two pieces of information. We need to reconstruct a tree looks like this. And yeah, so this is a trivial example, has only one node. And also, of course, the pre-order and the in-order will be the same, and only one node is. Yeah, so this very trivial example. This question was asked by Amazon, Microsoft, and other big names. So it's kind of popular, and it has almost it's more than 6,000 likes. So yeah, let's get started. And I constructed another example that help us to understand, and also walk through a little bit on the algorithm. I think it's easier to explain with an example. So let's say, I think this example is it's exactly as this one. I'm gonna walk through how we can solve this. So we have 3, 9, 20, 15, 7 for pre-order, and in-order for these numbers. And as you can see, the root, because it's pre-order, that's why the root always comes first. So that's why the root, we know right away, that's gonna be 3. And then this comes from the index of 0, right? We know for sure the root is equal to 3. And then the in order is at the second position. Okay, so this is very important information to get us started. And then we have the pre-order. Basically, it's a two list of concatenate each other. So one is 3, which stand alone, which is exactly the root node. And then we have the rest. Okay, 9, 20, 15, and 7. So 9, 20, 15, and 7. So that's the rest. Basically, they are the children of the root. Yeah, that's exactly what we explained. So basically, it has two parts, right? So pre-order allows us to separate very easily. So one part is the root, another part is the children. So, and then we can look at in order now, right? So for in order, the root is here. The left part, the left branch comes first, and then the root, and then the right branch. Okay, and as you can see, so the left branch has only one node, is just by itself, which is 9. The right branch is 15, 20, and 7. The root is in the middle. So, and this will give us very good information about how do we separate the left and the right. And also when we come back to the pre-order, we know that the left branch is going to be the left branch, the left branch is going to be 9, and then the 20, 15, and 7, which is exactly this part, that is by itself, is the right branch. And then the right branch is also is using a pre-order traversal. So the 20, that's going to be a root for the right branch, right? So as you can see, so 9, 20, and 15 and 7. So I think that's enough to get us started for the algorithm. So and then the in order is the 15, 20, and 7. So we know that the 20 is going to be the root node because it's in order. It's coming in the second. I think that's enough to get us started. Let's walk through the code together. So we will solve this problem using a recursion method. So for every recursion method, the first thing we have to do is to put in the edge case, the terminal condition. So if the length of the given list is equal to 0, that means there's empty list. It's going to return a none because there's nothing in it. That's why we don't need to construct any node. However, if the length of the given in order or pre-order doesn't matter, I'm just pick 1, so it's equal to 1. That means we are only given a list of it contains a single number in this. So it's not this case, and then we only need to return one node, and the value is going to be exactly equal to that number, that given single number. And then we will implement exactly what we just talked about. We construct a root node, and then the value is equal to the first number in a given pre-order list. So basically, we are grabbing pre-order list, grabbing the first number, and then that will be the value for the root node. That's exactly that. And then so we need to find a position between the in order So when we go back to the example, right? So the position for in order will be like here. And then we know the left branch and the right branch, the length in particular. I will walk you through why we need the length. So we find this. This is going to be in order pose. So in order position is equal to here, right? We use the index, and luckily there's one condition. So we are guaranteed with each value of the in order. Here this condition. Sorry about that. Pre-order and in order consist of unique values. That's why we can use the index function. Otherwise, you will just find the first index. So we are given that, and so this is why we can use the index in here. And excuse me. So and then we have the in order left and in order right. So this is two lists that is split from the given order. So basically, this chunk of code is basically grabbing the in order left, which is in this case is a single number 9, and the in order right. So it's a right branch, and this is the left branch. Okay. And then we also grab the length of that branch, the left branch length, and the right branch length. So taking the length of that of the two lists. So in this case, the left branch is going to be the length of the left branch is going to be 1, and the length of the right branch is kind of how many nodes actually is equal to 3 in this case. And then we have the trimmed pre-order that is equal to given order and the element from the second element all the way from the end, and that's because the pre-order after grab this guy, after grab this number of 3, we don't need the rest, right? So this is gonna be root node. We grab the number and then throw it out, and then this is the remaining is what we are interested in. So that's why we only need to grab the second number all the way to the end. And then after we finish the in order part, in order left and in order right, we need to finish the pre-order left and the pre-order right. And it comes from the trimmed pre-order. Again, the trim means that we toss the first element and we only look at the rest. And then we have the length that we determined before. Also, we have the right length that we determined from the Inorder before. And then we just grab it. This is how we can slice a list of like this, because we know exactly the length we are looking at. So it will be the length from the left. So basically we are grabbing, for example, this guy, we know the length is going to be 1. So we're grabbing only that element. And for the right branch, we come from the right. And then this is exactly the length that we need for 3 elements. And that's exactly doing that, right? And yeah, and then assign whatever is returned to the left and to the right. And then assign to the root node. And then we need to trigger running by calling the recursor and the original pre-order list and also the in-order list. And that's basically it. And in terms of time complexity, it's big O of n because we are traversing all the possible nodes between the tree. We go back to it, yeah. So it's big O of n, which is basically traversing all the possible nodes. In terms of space complexity is also big O of n. So for a tree that's completely imbalanced, we have to hold on all the stack, the recursion stack. In that case, is also big O of n as well. And then I don't think we store any other variables. Oh yeah, maybe we need some list here and there for the imbalance tree, and that takes a bit of space as well. So, but in total, it's still the space complexity is still big over n as well. Yeah, so that's so much for my solution. I hope you like it. If you do, please like this video and consider subscribe to the channel. That will be a huge support. And thank you so much for watching. I will see you in the next video. Bye bye.